Welcome to day 6. You got for your homework page 35 and 36 in your packets. We got a warm up you can put on the Wednesday box in your warm up sheet. So we want to find the surface area of this. So you basically have to find the area of all of the faces. Now just one thing to help you out, and then we'll have you pause the video to work on it and submit your answer. We're going to need this side when we're finding the surface area. Well, notice that's a right triangle, so we can do Pythagorean theorem. So we can do 3 squared plus 4 squared equals c squared. So that's 9 plus 16 equals c squared. Or 25 equals c squared. And when we take the square root, we get that c is 5. So we will need that length when going to find the surface area. So you got to find the area of all your faces, add them all up, see what that gives you, and that's your surface area. So go ahead and pause the video now and take a minute to do the warm-up. When you hit play, it'll ask you for your answer to the warm-up. All right, so let's start out. We've got our triangles. So for the triangles, we've got 1/2, 3 times 4, because 1/2 base times height. Well, 3 times 4 is a half. 3 times 4 is 12 times a half, which gives us 6. And we have 2 of those. So we're going to have 6 plus 6. And then we have 3 rectangles. Our 3 rectangles, we've got a 4 by 60. We've got a 3 by 60. And we've got a 5 by 60. The 4 by 60 is the bottom rectangle. The 3 by 60 is the left rectangle. And the 5 by 60 is that one that we can see right there. So this would be 240. And if you're not sure how to do that in your head, all you do is do 4 times 6 and tack a 0 on. So in the next one, similar idea, we'll do 3 times 6 to get 18, tack a 0 on. And then 5 times 6 is 30, tack a 0 on. So for our surface area, and maybe I'll add on to this that this is surface area equals. We've got 6 plus 6 plus 240 plus 180 plus 300. So the 6 plus 6 will give us 12. The 240 and the 180 will give us 420, plus the 300 will give us 720. And when you add those together, you get 732. It's an area, so we should have meters squared. All right, going over to the homework. So the first one, you just wanted to find the surface area. So we'll start by finding the lateral area. The first one is a triangular prism. So your lateral area is the 3 rectangles. So you have 2 that are 13 by 15, and then you have a 10 by 15 on the bottom. Add those all up, you get 540. And then the bases, the 2 triangles, you have 1/2 10 times 12, and there's 2 of them. Add those all together, you get 660 meters squared. In B, this is a trapezoidal prism. So the trapezoids are your bases. The 4 rectangles make up your lateral area. So we've got, for our lateral faces, we've got an 8 times a 9 for that left side, 18 times 9 for the bottom, and then we've got 10 times 9 for both the top and the right side. That adds up to give us 414. And then this part here is our area of the trapezoid. We have 1/2 the height, which is 8, times base 1 plus base 2, the 10 plus 18. Put that all in, and you get 638 centimeters squared because it's an area. For our cylinder, our lateral area is 2 pi times the radius times the height. So our radius was 7 there, and then plus our two bases, so 2 pi r squared. They wanted this to the nearest whole number, so we can put in the pi's in our calculator, and we get 1,232 feet squared. The next ones, we only wanted to find the lateral area. So this is a pentagonal prism. So the pentagons are your bases. So the lateral faces are those rectangles. Well, they're all have the dimensions 13 by 6.5, so we can just then multiply that by 5, so we get 422.5 inches squared. Lateral area of a cylinder is 2 pi times the radius times the height. So you got to take the 19.5 and divide by 2 to get your radius of 9.75. And again, we're doing to the nearest tenth, so we can actually put the pi in the calculator. So we get the 1,837.8 inches squared. And that was it for the homework. So we're going to be going to page 31. You'll want your calculators out. So we're going to look at volumes of prisms and cylinders, and then we're also going to look at composite volumes. Composite means more than one shape put together. We did composite areas in the first couple days of the unit, and now we're doing composite volumes. Well, let's see what you have on your reference sheet for prisms and cylinders. Notice right here they give us the volume of any prism. Capital B, remember, is the area of the base. So you're usually going to have to do some work to find that. So if your base is a square or rectangle, do your length times width. If your base is a triangle, got to do 1/2 base times height. Whatever your base shape is, you need to do the area of that base and then multiply it by that height. So there's always some work involved in finding that capital B. For a cylinder, it's basically the same thing, but your base is a circle. But they break it down for you separately. So a cylinder, you have pi r squared and then times the height. So if we go back up here, our volume for our prism, V was just equal to capital B times H. Again, where B is the area of the base. And then our volume formula for a cylinder, our base was a circle, so we have pi r squared times H. All right, so this first one, we're going to find the volume of our cylinder. So we're just using the pi r squared times H. So V is equal to pi. Our radius is 3. We'll square it, and then times the height. We want the exact volume, so that means we should not put the pi in the calculator. We're going to keep it in terms of pi. Well, 3 squared is 9. 9 times 8 is 72. So this is 72 pi. And when you have a volume, your units are cubed. So we're going to have centimeters cubed, and that's it. That's our exact volume for that cylinder. So the two ways they could word it, if you're not putting in the pi, they could either say find the exact volume like this, or notice in 2a, they say leave it in terms of pi. So we've got a cylinder here. Even though it's shifted, it's still the same volume formula. We're still going to do volume equals pi r squared times h. So we're going to do pi times, they tell us our diameter is 8, so our radius is 4. We'll square that. And then the height always needs to be the straight up and down height, which is the distance between the bases. And that'll give us 16. So because we want it in terms of pi, we will not put the pi in our calculator. We'll give you a moment to do 4 squared times 16 in your calculators. And really that's 16 times 16, so we should get 256 pi. And we just did a volume, so it's meters cubed. Now to find it to the nearest tenth, all you're going to do is you're going to put that in the calculator with the pi. So as a reminder, pi button is down here on the left. So when you go to put that in, you'll use that. And we'll give you a moment to see if you can put the 256 pi in and then round it to the nearest tenth. So we should get 804.247. The 4 is less than 5, so we'll keep the 2 the same. So we get 804.2 meters cubed. All right, moving over to page 32, we've now got a prism we're going to find the volume of. So volume of a prism is the area of the base times the height. Well, the shape of our base is a triangle, so we've got to find area of a triangle. Area of a triangle is 1/2 base times height in the triangle, where the base and height are perpendicular to each other. Well, we've got this side 6. We need to find this length here so that we can find the area of that base, the area of the triangle. It's a right triangle, so we can do Pythagorean theorem. We can do 6 squared plus b squared equals 10 squared. 6 squared is 36, so I have 36 plus b squared equals 100. We'll subtract the 36 over, and we'll get b squared is 64. And when you take the square root, we get b is 8. Now let's just talk about Pythagorean triples for a second. Pythagorean triples are integers that work out in the Pythagorean theorem. The most common one we saw in the warm-up. So if we go back to the warm-up, we had a 3, 4, 5 right triangle. That's the most common Pythagorean triple. It might be good to commit that one to memory, because then if you recognize it, you don't have to do Pythagorean theorem. Well, if we look at the one we just did, this is also a 3, 4, 5 triangle, but everything was just doubled. So you could also have a 3, 4, 5 with everything tripled, where it's 9, 12, 15. You could have 3, 4, 5 where everything's quadrupled, so 12, 16, 20. So being on the lookout for those can save you some time so you don't have to do Pythagorean theorem. All right, so for our volume, we first got to do the area of the base. Well, the area of our base is a triangle, so we'll have 1/2 our base times our height. So that takes care of the capital B. And by h, we mean the height in the entire prism, which was 12. Well, 6 times 8 is 48. Take half of that, you'll get 24. And then 24 times 12 gives you 288. And we don't have units, so we'll just write units cubed. And again, you don't have to do that in your head. You can just do that in your calculator. Moving down to the bottom, we've got a trapezoidal prism. Our volume of a prism we have right from our reference sheet is area of the base times the height. So our base, because it's a trapezoidal prism, is the trapezoid. Our area of a trapezoid formula, you have 1/2 the height of the trapezoid times base 1 plus base 2. So we'll fill that in for capital B. We have 1/2. The h here is talking, on the left, is talking about the height of the trapezoid, which they told us was 3 inches. Our base 1 and base 2, we have 16. And then this would be 8 here. So that just takes care of our capital B. That's the area of our base. Now the height in your prism is just the distance between the bases. So our height in the trapezoidal prism is how far are the trapezoids apart. Well, the trapezoids are each 12 inches apart. So we'll have 12 for the height of the prism. We'll give you a moment to put that in the calculator. And remember to put units on your answer once you get it. So we should have 432 inches cubed. All right, next we're going to look at some composite figures. So composite figures are just multiple shapes put together, and we're going to find the volume of those. So our two shapes we have here for this backpack are a rectangular prism, so the bottom there, and we have half of a cylinder. Well, a rectangular prism is area of the base times the height. And then we'll have to add on the area of half the cylinder. Well, a cylinder is pi r squared times h, and we'll have to put a half out front because it's half of the cylinder. That cylinder is just turned on its side. In our rectangular prism, the base is a rectangle, so it's just 12 by 4. And then the height of the rectangular prism is that 11 that's there. Plus a half pi. We've got to do our radius squared. Well, imagine this was a full circle here. The radius would just be this length. Well, if the whole thing there is 17 and we knew this was 11, that leaves us 6 for that radius. And then the height in the cylinder is the distance between your circles. So the height is just this length here, which they told us was 4. Now notice it does not tell us to round. So we're going to have to do this in terms of pi. The first term is not going to have a pi, the second term is, so we'll have to keep those separate. If we do 12 times 4 times 11, that's going to give us 528. 6 squared is 36, times a half is 18, times 4 is 72. So that'll give us 72 pi. And it's a volume, so we have inches cubed. Those two terms are not like terms, so we cannot combine them, and it did not tell us to round, so we do not want to be putting the pi in the calculator. Next one, we got another composite figure. So it's pretty obvious how to split up the shapes in the last one with the rectangular prism and the cylinder. Here we have a couple options. We can either chop that top part off horizontally, or we can chop vertically on the right side there. I'd say let's chop it like this. And we'll do volume 1 for this thing, and volume 2 will be the rectangular prism on the bottom. So for volume 1, it's a rectangular prism, so we got to do area of the base times the height. Well, we know this dimension is 4. If all the way up is 9, and this is just 5, that leaves us 4 for that part as well. So area of the base will have 4 times 4, and then the distance between those bases is 12. So if we multiply that out, we'll get 192 for that first volume. For volume 2, our area of the base will have 12 times 16, and then the height is just 5. And that'll give us 960 when we punch it in the calculator. So our combined volume is just 192 plus 960. Those are like terms, so we can combine them, and we'd get 1,152. It's a volume, so we'd have meters cubed. Alrighty, and our last one for today, we'll give you a moment to read through the scenario there. So essentially, we just need to find the volume of this composite figure. There's a couple ways we can divide it up. Let's, in this one that's kind of standing upright, let's cut off that part. we'll call this part volume 1, this part volume 2, and then the bottom brick is all together. We'll say that's volume 3. So in volume 1, we only have one of the dimensions right now. We have the 8. 40 was going all the way across. So we've got to figure out what that top dimension is. Well, this here is 24. This part was 8. That would make this to be 16. We know this is 8 from the 8 way over on the left. And based off that 16, if the top was 40 all the way across, that would tell us that this length here in volume 1 has to be 24. To find the height for that volume 1, we've got 8 and 8 way over on the right, so that would make this 16. So for volume 1, our area of the base is the 8 times the 24, and then the height would be 16. If we punch that in the calculator, we'd get 3,072. Volume 2, we've got 16 times 8 for the base, times the 8 for the height, and that'll give us 1,024. And then similar idea for volume 3, our base is a rectangle, so length times width, and then times the height of 8, so we get 4,608. And our overall volume, we'll just add those 3 up, and that'll give us the volume of the composite figure. So altogether, that'll give us 8,704 inches cubed. Now later in the unit, we'll take problems like this a step further. We'll learn how to do it if they give us like a cost per cubic inch of the concrete. So maybe they tell us that it's 2 cents per cubic inch for the concrete. What is the cost then of making this custom block? And we'll learn how to do that later on. All right, so you've got your homework assignment to do. Make sure to upload that tonight. Have a great rest of your day.